applying AI to MBSE. We got a lot of interest. I'm glad to see a lot of folks coming on. So let me go ahead and hand it over to Rosemary.
Thank you. So hi, everybody. My name is Rosemary Kioko. I am the owner and CEO of System Strategies and Analysis. And thank you so much for allowing us to present this topic today. Obviously, something really exciting for us. We're passionate about MBSE, and so we saw it befitting to just also go into applying AI to MBSE and see where this goes. So agenda for today, we'll do a brief introduction. We are collaborating with our partners, AI Revolution Lab. So we'll let them introduce the team. I will introduce the SSA team. And then we'll go into a little background in terms of AI and MBSE and how it all kind of ties into what we are trying to do. Then we'll dive into the AI system design and specifically the use cases. We really, truly would appreciate your feedback. So feel free to, this can be more of an interactive, really presentation in terms of that. And then we'll go into the AI system itself, the model, and what we are proposing, what we are envisioning, and in terms of how the interaction, with the LLM, the large language models, and the AI Revolution Labs will go into that, into details. And then we'll open it up for questions after that. So SSA is a small woman-owned engineering services business. We specialize in systems engineering, specifically space and ground systems. Right now, we are supporting NASA, space communication and navigation on their systems engineering. And again, mostly we do focus on model-based systems engineering. We also do training in MBSE. We've collaborated with some of the MBSE experts, including Intercac and Sandy Frankenthal. I think everybody is familiar with Sandy. We are collaborating with them on the awesome training, and this can also be found on our website. So with that, from our team, we have 3 amazing engineers who have been working on this. Keenan Morabat is a systems engineer at SSA supporting NASA scan at this point. Dylan Reed is also another one of our systems engineers supporting NASA, as well as we're doing some DAPA work as well. And Jay Kibunja is our intern for the summer, who is a computer science major, and he's been supporting us on the AI side, is navigate this. So next, I'm going to hand it over to Matt from AI Revolution Labs to introduce themselves.
Thank you, Rosemary. My name is Matt Fisher, and I'm one of the co-founders of AI Revolution Labs, and we specialize in helping organizations and companies getting up to speed with where AI is today. We have a consultancy arm, and we also have a lab where we build AI tools, and we also help companies like SSA. We team up with them and make things happen on the AI side as a second sounding board. A little bit about my background. I've been in the business, brand strategy, and innovation strategy field for a couple of years as a consultant, and I love emerging technology. And then Mike's technical project manager, and he's an AI developer. And you have our info there. Feel free to reach out. Now I'd love to turn it over to Keenan so we can get right into what's really exciting about what we're talking about today.
Thanks for the intro. I'll begin by providing a brief background on AI. So these days, AI certainly is a hot topic. It's no secret that it's playing a big role in key technology innovations and developmental processes with a wide and growing range of applications to a variety of industries. So given that, it's important to understand what an artificially intelligent system means, particularly since the term gets thrown around a lot. Basically, there are 3 capabilities of an artificially intelligent system. So the first is generalized learning, where a system can apply some training it's received in an unfamiliar context. And second is reasoning. So that's where a system can mimic human reasoning capabilities to make logical decisions. And the last problem is problem solving, which uses a range of methodologies like search algorithms and optimization techniques in order to achieve a desired solution. Within the field of AI, there are a number of forms an AI system can take or implement as components, each with different applications. So perhaps the most commonly known form of AI is machine learning. It incorporates a set of data to train an AI system, whether that learning be supervised or unsupervised. So the distinction there is that supervised learning uses additional provided data labels to yield an optimal solution, while unsupervised learning simply looks at a raw data set and makes sense of it to form some sort of understanding. So machine learning can be seen to be used in image recognition and spam filtering applications. Next, natural language processing is used by AI systems to understand, interpret, and generate human language, and is commonly applied in speech recognition and text analysis, as you could conclude. It also commonly applies a large language model to do so. So next, the field of robotics covers AI systems that use a range of sensors and other mechanical engineering systems to interact with the physical world. So that's like with a basic industrial or more advanced humanoid robot. Next, expert systems, those imply mimicking human reasoning and decision making, and they've gone to the point of being applied to facilitate some pretty critical decisions like medical diagnoses or financial investment. And lastly, deep learning essentially uses neural networks which replicate functions of the human brain via nodes or neurons to acquire very advanced knowledge from data sets. So it's also used in speech recognition as well as in pattern identification. So that's kind of provide some context for AI, but on the MBSE side of the house, I assume it's well known here that what MBSE can do in a complex system architecture development, namely improving communication, enabling reuse, maintaining source of truth, and verifying design completeness, and much more that I'm sure I've missed. So these benefits can be realized by MBSE, but tend to only do so when resources are invested early to avoid high costs later in the development lifecycle. Unfortunately, this need for upfront investment is a big contributor in why MBSE isn't more widely used. So it tends to either be a deterrent for programs or a point of failure. This chart shows program lifecycle costs over time in a typical development process, where the blue line is associated with an MBSE development lifecycle, and the red line is associated with more traditional development lifecycle. So the early upfront investment in the MBSE curve can be seen clearly early on. It's often due to things like learning curve associated with modeling, committing resources to training, and also like combing through system architecture early to avoid rework. So kind of putting those efforts early. But what we ultimately see is early efforts pay off later in cost reduction due to rework when change costs are higher. Taking that into consideration, we also looked at the systems engineering V model. So we kind of compared the two graphics, where on the right you can see in the V model that it's a typical systems engineering development lifecycle over time from left to right. So comparing the two graphics, we notice the upfront investment of the MBSE development lifecycle coincides with requirements and architecture portion of the V model. And so based on that, we decided to look at applying AI to that phase to ameliorate those upfront investments, and I guess the obstacle of that of an MBSE development lifecycle. So with that in mind, we established a purpose for our projects, which is firstly to apply AI to MBSE, particularly at the requirements and architecture phase of the lifecycle, in order to mitigate upfront costs that tend to be a problem. The purpose is to also improve effectiveness and efficiency, essentially quality and schedule, by quickly developing and modeling well-written, clear requirements and their associated architecture. So in doing so, we believe we can springboard the MBSE development lifecycle over the upfront investment curve and through latter development phases. So as such, the AI system we are developing has some knowns. Namely, we intend to feed it some context by user system information. So this would provide the AI system details on what the user is developing in order to correctly place it relative to what's been trained to the system. Next, the user system requirements are provided, whether complete or not. If incomplete, the AI system should facilitate in the requirements writing process. However, if already complete, it should attempt to improve on those pre-existing requirements. The last input, and perhaps the most crucial, is a requirements database that will essentially train the AI system in the relevant field of the user system. While we are currently developing for application to spacecraft development, working with spacecraft requirements, the intent is that the AI system can be applied to any sort of system. So it's just a question of getting access to or building the appropriate database of specifications that would eventually train the AI. As far as the outputs we want from the AI system, at a high level, we want it to provide quality user system requirements and a SysML model architecture, SysML being the systems modeling language, of course. And as such, the solution we've arrived at is a narrow AI system that uses natural language processing and hybrid machine learning, so it's both supervised and unsupervised learning, to generate the desired outputs given the aforementioned inputs. So the narrow prescription simply to emphasize that the AI system is intended to facilitate the user in the specific tasks of requirements and architecture development, rather than completely replacing the user altogether. So that would be more deeper AI, I guess. But in this case, we're looking at just a narrow AI. So with that, we've come up with a number of use cases for our AI system, and they're all developed with the systems engineer in mind as the end user. So that's why you see in the diagram we have all the use cases are connecting to the systems engineer. And so those use cases namely are provide requirement autocomplete suggestions, categorize requirements, classify requirement prioritization, generate requirement architecture, model requirement relationships, measure requirements quality, suggest requirement improvements, which extends to eliminating requirement redundancies. So I want to emphasize here, I'm going to kind of go into more depth as far as these use cases and I guess the associated user stories, but I want to emphasize that, we really want to get this group to take a look at these and tell us, if we're missing something or if we're misrepresenting something here with our use cases. At a high level, this is what we have as a starting point for our AI system. So here you can kind of just see each of the use cases in this table that were just shown on the previous diagram. However, we've also added the user stories for each use case. So I'll just read through them and also give you a chance to obviously go through all of them. Like I said, we really want to get some feedback here as far as the specifics here of these use cases. So starting with provide requirement autocomplete suggestions. So the user story there is obviously just with all the user stories, we're keeping the systems engineer in mind. So the system engineer wants to see suggestions for applicable requirements for their system. So that could be whether they're inputting their partial requirement text, and then the AI system would be referencing the database and the information that's been given in order to generate suitable requirement suggestions for that partial requirement, based on the given information. The next use case for categorized requirements, the user story is the systems engineer wants to group like requirements automatically, and they want suggestions on how to group the requirements based on the information provided, the lessons learned that are visible from the past similar projects, best practices, and so on. And notionally, that would implement some kind of clustering method to essentially look at the completed requirement set, user requirement set, and then spit out some categories that apply to that requirement set. Next, for classifying requirement prioritization. So for the user story for this, the systems engineer wants to rank relative prioritization of requirements using the mission context So what, it could be NASA mission categories like, for in the case of spacecraft, it could be a communication spacecraft that has certain emphasis on certain requirements. Taking that into consideration, the AI system can then prioritize those requirements accordingly. So that's based on the best practices and a defined prioritization from the specific program. So that would be another kind of input that the user would provide, which is something like a measures of effectiveness, where you're trying to emphasize certain requirements on top of, say, what's already associated with the selected mission category in the case of the NASA mission for spacecraft. Moving on, the next use case, generating requirement architecture. So that's, now we're kind of jumping into the modeling side. So the systems engineer wants to generate a requirements architecture, specifically a model from a set of textual requirements. So that, obviously would be in the form of a specification, and then generate the use cases from high to low level. So now this is kind of where we're handing things off to a modeling tool and generating that architecture based on the user mission requirements. Next, also associated with kind of modeling architecture, is modeling the requirement relationships. Systems engineer wants to add the traceability between all the elements that have been modeled. So requirements to requirements to logical architecture, functional architecture, basically full traceability, and then possibly identify missing links. Next, we're kind of jumping into requirements quality. So the next use case would be measuring requirements quality, and that's pretty straightforward. It's, the systems engineer wants to analyze the quality of requirements based on some input standards. So those standards obviously vary between organization, and so the idea is to allow those standards to be input or predefined, and then from there the requirements quality is then measured. Next is use case suggesting requirement improvements. So the user story there is that the systems engineer wants to receive suggestions for improving the requirements. Could be any part of it, the structure, grammar, syntax, taking into account the quality scores from the previous use case, and then that's being measured against predefined standards. And then the idea is that the AI system can spit out some improvements to requirements to essentially improve the quality overall. And last is the use case of eliminating requirement redundancy. So that's basically the systems engineer wants to basically prevent duplicates in requirements. So if there's any overlaps, it might not be necessarily that the text is verbatim the same, but it could be more contextual. There's similar capabilities, or there's some redundancy in a number of requirements. Well, then, the systems engineer wants to be able to analyze that and mitigate that. Those are the use cases and the associated user stories in a nutshell. So here, this is basically another view of the use case diagram that I showed a couple slides ago. It's just taking the same use cases and organizing them by their domain. So which subcategory of the requirements and architecture development process they apply to. As you can see, we have 4 of those subcategories defined. First being writing requirements, next is organizing them, and modeling requirements, and lastly, ensuring requirements quality. So yeah, each of the aforementioned use cases have been mapped accordingly to those categories, just to provide some more context to how we see them kind of fitting all together. So here we're just looking at a very high level system decomposition for our AI system at a very high level basic kind of diagram here, just a block definition diagram, where you can see that in our context, what we're taking into considerations, obviously the end user being the systems engineer, our MBSE tool, which is notionally Magic Draw. That, obviously Magic Draw being the most common MBSE tool that's used across the industry there. It would obviously be associated with the, I guess, the modeling use cases where we're trying to look at input textual requirements and then output an actual SysML model in that happen over in the MBSE tool. And then on the left side, the AI systems got some basic parts to it. Firstly is a requirements database. So this would be essentially what trains our AI system to then form the use cases. It would essentially be providing it that knowledge, that background knowledge to be able to do analysis on requirements, suggest improvements, categorize them, prioritize them, and so forth. And like I said, the idea is that the application as a whole can be any system, so it doesn't need to be particular to a certain industry. It's just so long as we get the right database provided or built. The idea is that's used to perform some retrieval augmentation, which feeds a large language model. That's essentially what's performing the natural language processing. Michael will be talking about that more in depth. However, at this high level, we're just identifying that these are components of our AI system. Next is the MBSE tool API plugin. So that essentially is what's going to allow us to interface with Magic Draw, or whatever the MBSE tool is, notionally Magic Draw. I know that for Magic Draw, they use Open API as their API. There are ways you can design plugins that allow you to interface a range of applications. And the last component listed there is the RQM tool. So that's something that's, I guess, pretty standard. RQM tools are something that are somewhat commonplace within organizations based on those organizational standards for requirements. Essentially, you feed it requirements and it spits out quality scores. And the idea is to use that, to leverage that, and essentially improving requirements portion of the AI. So it can take scores, identify what has low scores, suggest improvements to achieve some desired threshold of RQM score. So here I've just drafted up kind of top level IBD that shows how the parts that I showed on the previous slide kind of interact together. So you can see the top left part is the user in kind of purple, blue. Then below it, in red, we have the MBSE tool, which is Magic Draw. And then on the right, we have our AI system with the identified subcomponents: requirements database, large language model, RQM tool, and the MBSE tool API plugin. So the idea is that the user is passing some system information as well as their system requirements, whether complete or partial, to the AI system, as well as inputting whatever requirement standards are relevant to their development. And in turn, the AI system is spitting back some requirement suggestions, categories based on the clustering, some priority measurements. So, doing the prioritization based on the input user system information, which, might include like measures of effectiveness. And lastly, like requirement quality scores, which are spit out from the RQM tool. And then in the background, the AI system is interacting via the MBSE tool API plugin to provide the MBSE tool with the model elements and model relationships of an actual, SysML model, and that complete model architecture is then in turn passed back to the user. So that's kind of top level view of the AI system is how it's functioning to achieve the use cases, obviously, that were mentioned earlier. With that, I'm going to pass it over to Michael. He's going to speak a bit more about large language models and kind of the state of the art.
Yeah, thanks, Keenan. Hi, everyone. Michael Atherton, co-founder with Matt at AI Revolution Labs. I have been reading some of the questions, a lot of good questions. It sounds like, this isn't the first time you guys have heard it. Everyone use ChatGPT, and hopefully I can address some of those and the questions. If not, we can kind of dig into some of those later. First, just looking at how we, interact with these LLMs, there's a lot of, I kind of categorize them in, three different, large buckets. You can train these large foundational models, and that's, you think of the ChatGPT 4, the Google Bards and the Palm 2s, and you won't be, this is not very efficient or really cost effective or even doable for anybody without millions of dollars to train these models. As you can see, ChatGPT 4, is trained on 13 trillion tokens. A token is up to 2 to 4 characters, so a little less than a word, and then over, let's say 1.8 trillion parameters. And there's varying different information online how much it costs to train these models. But with a partnership with HP and that ChatGPT has or OpenAI has, it didn't cost them this much. But if they were going to train these on the new H100 NVIDIA GPUs, you're over 100 million. I've seen numbers up to 200 million to charge to train these large models from scratch. Similar story for Palm 2, which is Google's new model. Also not as big as ChatGPT-4, but still way out of the reach of any normal, a medium or size business. So the what we have then, the next bucket is fine tuning, and this may, some of the questions were, are there specific models for MBSE or different companies or industries? This is where you would take an already trained model and you fine tune it. And actually, ChatGPT 4 is in essence, a fine-tuned model of 3.5. Granted, 3.5 was trained on something like 700 billion tokens, and if you look at the size difference between that and ChatGPT 4, 13 trillion tokens, it's much larger. But they're also a much larger. The parameters are the weights, how you direct and kind of point a model, and so that's why ChatGPT 4 answers. Assuming you guys have used that, it's much more clever and responds much better. So there's two big things I think with fine tuning that are important. You can direct the LLM for specific use cases. This is not really, if you want to give an LLM, knowledge and information, it's fine tuning is not, that's not how you would use fine tuning. You want to maybe direct it for a specific tone. Example, maybe if you want to have it, answer very sarcastically with everything, every answer, you can train it to, that tone. Or if you wanted to output everything in, say, JSON or a specific format, those are really good use cases for fine tuning. However, it's expensive, and that's not where we would start, because if you want to fine tune a model, you could start with, say, 50 to 100, key value pairs or like prompt pairs, up to a few thousand, and that's very expensive to fine tune that model, and then to get a result and say, am I off? Do I need to fine tune it better? It takes a long time. So that kind of leads us to the third bucket, which is retrieval augmentation, which Keenan alluded to. And in this example, you take a specific corpus of text, or we basically vectorize these. In the case of with SSA, the requirements that you have already you have a set of requirements that you've used over and over again. And you can take those set of requirements and you can vectorize those, and you do a query to that vector database first to get examples that are similar to what you're trying to accomplish, and you feed that into the language model with a lot of there's a lot of prompting in here and then the output would be again, like Keenan mentioned, those use cases, something specific to what you're trying to accomplish. This is a very iterative process. It's not an exact science, and there's a little bit of finesse in here, but you can get a lot of very good results with prompting. And the best case, you start with the prompting, see how far you can go, because you can get feedback very quickly, and then you back into fine tuning the model if there's gaps. So hopefully that kind of answers some of the questions we had in the comments. Because in the world of AI, we measure time in weeks to months instead of years. It's kind of like dog years here. So this week we had a few announcements from OpenAI, which were, I think, worth noting. They have an OpenAI enterprise offering. They're SOC 2 compliant. They're data encrypted in transit and rest. And pricing is still to be determined. You got to call them and find out how much they want to charge you. But the push for this, because there was always a risk with these using ChatGPT for any proprietary data, any IP, because it would leak into their general model. When you use ChatGPT, they use that for their reinforcement learning for their models. But now they have, with this enterprise offering, the goal is to lock that down, and no one has access to that. There's no training to mitigate that risk. Also, this is the first time we have access to their models to fine tune, which is very, very cool. So right now it's ChatGPT 2.5, ChatGPT 4 will follow soon, and then we can use these models. At the moment, there's other guys kind of nipping at OpenAI's heels, but ChatGPT is the best largest and most comprehensive model we have. Anyway, that's my piece. I guess if we have any more slides. Oh yeah, that's right. Questions.
Yeah, real quick, Michael, there was a couple questions on your first slide. They were asking about trillion. Is that a typo, supposed to be trillion, or is that an industry term?
Oh, no, that's just it's probably a typo, just trillion. Yeah, more than billion. Is there any questions about this specifically? I don't know if I answered all the questions on the chat. And other use cases that you guys have. We're always looking for other use cases, or anything specific to this presentation or the utilization of these LLMs.
So this is Ron Carson. I put a question about another use case because it seems to me the flow that you had where you're inputting requirements and then the AI builds your architecture is exactly backward. What you really want is the user defines the architecture with whatever help you get from the AI, and then you want AI to actually write the requirements for you from the architecture. But I didn't see that use case, and your flow seems to go the other direction.
Yeah, you are correct. I've seen that specific slide, but that's
it's one that had the 3 big blocks on it with the system magic draw there, that one. I notice the user should be defining the architecture, and then the AI system generates the requirements.
Yeah, and I guess I should clarify. This might be misleading. I think by complete model architecture, the implication is like just a digital model of the architecture, not necessarily telling the user what the architecture is.
So is the architecture inputted by the user what is meant by user system information?
Yeah, so that's kind of a bit of a catch-all. We can be more specific about what exactly the inputs are.
Okay.
But yeah, I think you hit the nail on the head there.
Then I would like to see that other use case where you auto-generate the requirements from the architecture. Mission, MOEs, who the stakeholders are, what they care about, what the external interfaces are, and there's what are the systems I got to interact with, what are the key performance parameters, and here's my architecture, and then write the requirements.
We might have miscommunicated with the use case in particular, but that's kind of what we meant by providing the requirement autocomplete suggestions, right? So it's taking in all that information, and it might not. I suppose the use case is a bit, it prescribes a solution in that it's saying, well, we want it to, generate these in the form of autocomplete, like rather it can just generate a complete set of requirements based on.
I was going to say autocomplete suggests the user's got to write at least the system shall characteristic or function, and then something fills in the blank. And I'm talking about, no, I want the AI to actually write all the requirements, at least all the functional requirements I can derive from the architecture.
Yeah, no, that's a good point. I'll write that down. I think we can rewrite that one.
Yeah, that would be much more useful from my perspective.
That would be interesting in a maybe a fine-tuning scenario. Just kind of thinking out loud here. Anyway, that's thanks for bringing that up.
There are plenty of tools available right now that can critique your requirements.
Yeah.
The question is, do we actually have some tools that will write the requirements when we need to have written requirements from all the engineering work I've done in defining the architecture? That to me would be a real benefit.
Yeah.
Okay. That was my point. Okay.
Thank you. Yeah.
This is Lou Waitcraft. It seems like you're relying a lot on ChatGPT. And I played around a lot with it from a requirement standpoint. And I found that it has no intelligence. It cannot do any thinking whatsoever. It just puts words together and has no concept of what the words really mean. And the example is I would give it a poorly formed requirement and say, critique that requirement. It would do a fairly job of saying what some of the issues were with the requirement. There's an ambiguous term or something like that. Then I'd say, rewrite the requirement without those defects. It would give me another version of the requirement with more defects. It wouldn't critique its own output to give me a well-formed requirement. I've been doing some work where I've been given a user need or user requirement that was poorly formed. It had a lot of defects in it. When you do an analysis of that from a human engineering analysis standpoint, you find out For one, what was the real intent? And then to meet that intent, I actually needed 3 separate requirements to meet that intent. That capability just doesn't exist within ChatGPT. Any comments on that?
One of the big misconceptions is that what we have is like GPT or GPT-4 and that's it. A lot of the trends nowadays are building something on top of GPT-4 that actually acts as guardrails. So when there's specific like industry knowledge, it's put it within a box outside of the language model, and the language model then can pull from that and document just from that. So it's driven by the LLM, but at the same time, we create a very industry specific box that would increase the accuracy of that data. But if you're going straight from the large language model, like I would expect a lot of hallucination and like misrepresentation, and it sounds confident, but it really is off. So I think that's a different way of looking at things, and that's probably where the industry's headed a little bit with AI, is thinking about an industry specific attachment to the large model.
Yeah, thanks, Matt. In this allude, that's when we were talking about retrieval augmentation. There aren't very many use cases besides, hey, write me an essay if you're in school or something. That I would really use and trust. Just the knowledge that ChatGPT-4 has a ton of knowledge, but if you want something very specific, yeah, that's where we would put the requirements or architecture designs inside of a vector database, and then when you do a query, you query that vector database first for those specific requirements, and then you feed that into the language model. We're not using the language model for its knowledge, rather we're using the language model for its ability to reason and really use the constraints that we give it, plus the information we give it to then write those requirements. So you are 100% correct. If you just go into the UI, OpenAI or Chat, GPT-4 in that UI and try to get some of these requirements, you're going to get hallucinations all over the place. So retrieval augmentation and fine tuning is a way to mitigate that risk.
One of the problems that I have is a lot of the tools focus on set of rules that are defined, like the NCOSE guided writing requirements has set of rules that contribute to quality requirements, and they are maybe necessary, but they're not sufficient. A lot of it goes into the system engineering that goes into developing that set of requirements. And so, like I was saying, I have is that defining requirements is not an exercise in writing, it's an exercise in engineering. And that's, one of the problems we have. And the other problem is that with the focus on rules, they tend to ignore the set of characteristics. And so, like, one of the characteristics is a requirement feasible. And how would an AI determine if a requirement's feasible or not, or a set of requirements is feasible?
Yeah, I wouldn't rely on the AI to do that. I think part of this, and one thing to mention is, like I said before, this is a very iterative process. And one of the reasons presenting today is, if there's somebody who would offer to be, a beta tester, so we can iteratively work through this. But you have to have those defined set of requirements, built out by an engineer, and then those constraints. Is this feasible or not? A lot of this would have to be, built in, from you guys or from the community, and then we can, feed those into to build those requirements or complete those requirements. So I don't think that relying on the AI to come up with those on its own, or ChatGPT rather, until you can build some of those in with a fine tuning model, although that comes after the prompting part. But I think that we will eventually get there, and we've seen some pretty good performance so far.
My view is that AI, I don't think will ever replace the engineer completely. So in that respect, the AI is a digital assistant, kind of sitting on the engineer's shoulder. It kind of enhances the engineer's ability to do engineering, but it's not going to replace the engineer's expertise, knowledge, and wisdom.
Yeah, I don't think anybody's intention here is to replace the engineers. I agree. I think AI, it's a very useful tool. It's an arrow in your quiver. It's not magic, but it can make you much more efficient.
And one other thing I'd like to mention, maybe going along with that, we look at AI right now as text to like text based with GPT and some of these other ones. But if you look at the visual, like Stable Diffusion and some of these other visual AI tools, they are getting so much better. In the last 8 months, you can see like just huge improvements that would take years in any other industry. So that's also something to keep on your radars as well. that over time there is a visual aspect to AI that will get better and better.
So there's quite a bit of comments and questions noticing in the chat. I want to ask Tammy Blazer. She mentioned, have you looked at the EASA W-shaped development model for learning assurance? I haven't looked at that. I'd be interested to hear more about that. And yes, admittedly, Magic Draw with a SysML plugin is essentially Cameo. So thanks for that correction.
Yeah, the W-shaped development cycle has a lot of interesting information, and it's it's out of the ESA organization, so they're European space and aeronautics safety oriented organization, but they've looked at deep learning and various other AI concepts, and from the standpoint of assurance and safety. So I don't know if that's outside the scope of what you're trying to do, but you might want to at least look at it because it does have some good ties into other use cases and other work that you may do downstream as you modify your requirements work with model-based system engineering.
Absolutely, thank you.
And we're hoping that we can be more collaborative. If anybody has interest in what we're doing and wants to chime in, we look at AI as a very collaborative thing, especially when you go into different industries and build tools, that the more collaboration, the better the product and the output is. So that's just a little encouragement to everybody. If you're interested in this space or see the future headed towards it, and you guys are willing to help us build the best AI assistant for the specific industry, we're all ears.
Yeah, thank you so much, Matt. Yeah, and to piggyback off of that, yeah, we're also looking to putting together a white paper that we can potentially present at the Inclusive Symposium. So again, we are open for collaboration on this work. So reach out to us and see what we can do together. We truly do appreciate the feedback.
This is Kevin. You had talked a little bit about working with NASA, or a couple of your folks are working with NASA. Is this being utilized, and how far along is it? Is it providing that domain expertise with the space exploration, and you're starting to get results out?
Yeah, I can speak to that. No, this is not being applied to anything yet. And so again, we just started. We are still in the initial stages. We've been working on this now, I think, for 3 months. So we really just wanted to get the larger community feedback, especially SC community on the use cases to make sure we're on the right path. But we have had dialogue with NASA, obviously. Some of the folks who are leading the MBSE effort, they did give us some good feedback on this as well. We're looking to talking to DoD as well, and to see what we can do and how we can expand this work.
Okay, thank you. Yep, open it up for any more last minute questions, comments.
A lot of good questions in the chat.
Raymond Wolfgang here. Just remember seeing something from IBM a couple years ago, IBM Watson. They were playing in this space in some way. And I don't have much detail beyond, they were, I think, exploring some early AI concepts. Have you checked out their work, or is that on your radar? Thanks.
I don't know how deeply SSA have, but I had a chance to meet with some of the higher ups in the Watson program in Washington, D.C. a few years ago. And it is definitely one of those things where it's evolving, like ChatGPT is. A lot of it was deeper on the machine learning side versus generative AI, but not to say it doesn't grow all the time too. So I do want to look deeper into that in this specific use case.
Thank you.
So this is the Wheatcraft again, and I'm co-hosting this with Kevin. Seems like there's a lot of interest in this topic. I assume between now and toward the end of January, you plan on making some progress.
We do, yes. We do plan on expanding on this work again. Thank you for the feedback, and also getting funding to actually even grow it further. So we are working on that. And yeah, again, if anybody knows folks in this area want to collaborate, please reach out. Let us know what we can do together.
So the requirement working group, we have a pre-session before the international workshop. It's all online. We usually have several days of presentations. If you have some updates to this that you'd like to share, get a hold of us. We can include you in a schedule for that, because it looks like there's a lot of interest in this. We had over 96 people signed in at one time. So if you can plan ahead to that.
Yeah, that sounds great. Again, thank you so much, guys. We really do appreciate this and the opportunity to present. And we really would appreciate your feedback. So if you can reach out to the Inclusive AI Working Group. Actually, they're the ones who led us to this group. I think I spoke to Barkley Brown, and he's the one who actually suggested we come to this group.
Well, we thank you for your time. It was certainly a highly attended topic, very interesting for many folks. We want to thank y'all, and I think we're at time, so I'd say we would conclude for today.
Thanks, everyone.
Thank
Sounds
you.
good. Thank you.
Everybody.
Thanks very much. Very interesting.
Thank you.